Hi students, yesterday we have discussed about a dynamic device, what you call the AC generator. How AC generator manufacture or produce AC current we have seen, right? A schematic diagram I have explained how to produce AC EMF, AC voltage. Today we have another device that is called a transformer. Transformer is a very important and also it's a very magic device. It is a static device because there is no moving parts in it. But in the case of a generator, the armature is always rotating in the space between the two poles of a strong magnet. So that has dynamic parts, moving parts there. But in this instrument, there are no moving parts. That is why it is called a static device. This device is used to increase the voltage. Applied voltage is less and the resultant voltage can be high. To convert a low voltage into high voltage or to convert a high value of current into low value of current, right? When you change a low voltage to high voltage, then current will be changing from high value to low value. This is the theory of a transformer, right? So in this, a transformer actually works on the principle of electromagnetic induction, right? It mainly consisting of two windings. One is the primary winding. This is called primary winding, having a number of turns is equal to NP. And another winding, what is called secondary winding, that has another certain number of turns. Both are wound on a common core. This core is a laminated soft-end core it is used. There is a reason why laminated and also soft-end core is used to minimize certain kinds of losses that can happen in this instrument. We are using laminated soft-end core. So this is not a solid, a single conductor, but it is made of laminations. Lamination means thin sheets are used as the core of the transformer. So what's on the principle of what? What's on the principle of electromagnetic induction? There are two kinds of transformers. One is called a step-up transformer and the other is called a step-down transformer. This uses of transformer is very interesting. It is used for transmitting voltage, power from one end to another, right? Transmission and also distribution. Both these purposes transformers are used. So step-up transformer and step-down transformer, I said, right? At the generating center, that means power station, where power is manufactured, at that place, a transformer is installed that will be step-up transformer. Because from the power station, the power is transmitted to long distances with the help of a transformer. Without the help of a transformer, it is difficult to transmit the power from one place to another, right? Because a transformer transfers current in many conditions. Suppose that a transformer has to transmit 100 watt power from one end to another end. That can be done in these various methods. For example, 1 volt into 100 ampere, that is equal to 100 watt. The current value is more and the voltage value is high. So if the current value is high and voltage value is lesser, the current has to flow from one point to another manufacturing point to the domestic point or where the power has to be used. With very high current, when it is sent, that current has to flow through or come through line wires. Through line wires, when current passes, due to heating effect, a large amount of power is lost in dissipation of energy. That means unwanted source of energy into unwanted source of energy that will be converted. There is formation of heat. Okay, this can be done like this. 1 volt into 100 watt is equal to 100 ampere is equal to 100 watt because 1 volt into 1 ampere is equal to 1 watt. You must remember that. The same thing can be done like this also. 10 volt into 10 ampere, that also equal to 100 watts. 100 volt into 1 ampere, that also equal to 100 watt. 1000 watt into 0.1 ampere, that also equal to 100 watt. 10,000 volt into 0.1 ampere, that also 100 watt. Which one you would prefer? You would prefer the last condition. Why that? Because from the transmitting center, current has to be sent through line wires only. So current cannot fly through the air and reach from one point to another, right? It cannot travel through air medium, and reach to the other destination. That is not possible. So to current to send from one point to another, we need cable wires. Cable wires are made of metal. Metals offer resistance. So if high value of current and low value of voltage, with which if the power is transmitted all along the journey, the flow of current, large amount of current will be converted into heat, and the power will be, loss of power is very high. So that is really a very big loss. That is what we do most of the time is the voltage values increased and the current values minimized. So the power transmit is same only, but the voltage is very high and the current value is minimal, very very less. In power lines that you see in our locality, also power lines are coming from substations, are also in the power stations that are at a very high height also, because the voltage is very high. But in those wires, the current value will be very, very less. Current value very, very less means the resistance, if it is, that means the transmission wires are very thin. Most of that is also a question most of the time. Transmission wires of higher power lines are very, very thin. So does it make a lot of loss? No, because in transmission lines coming from power stations to domestic places carries very very less current, because transmission of current with a high voltage and less current is only profitable. Otherwise, it is a great loss. That is why power lines of the cable used is of very very thin. That is the resistance is very high. Though the resistance is very very high, that does not make any difference, because that contains only very less amount of current. Hence the loss of current by heating effect is very very less. But coming to the domestic places, our line wire which is moving around our locality, that has cable wire which is thick as compared to power lines. Why that? Because in the domestic line, the wires are domestic line wires are having more current and less voltage. When voltage is less, current is increasing. When voltage is more, current is decreasing. This is the theory of transmission and distribution of current with the help of transformers. So transformers works on the principle of what? Yeah. Two kinds of transformers are used. In this case, also it is given here. 11 kV is that the producing center, right? 11 kV. This is a transformer. This is the schematic diagram of a transformer, right? So now this is a step-up transformer we are using. Here the number of primary, and this is the secondary. This is one transformer. In this case, NS is greater than NP. When NS is greater than NP, the voltage is increased and the current is made very, very less. And that travels to a long distance from the power station to the outskirts of a city, which is quite far away from the power station. Right? Now, this 11 kV voltage of the power is converted in 220 voltage, 220 volt. But current IP is more and IS is less. This is the principle of the working principle of a transformer. Now, this is taking the power with very high voltage and less current to a long distant destination. And here we have another transformer, that is a step down transformer, accordingly as the purpose, right? In our household or also in small scale industries and all, they don't need 220 kilovolt, they cannot use. So we have reduced it to a very small value, 11 kV or 5000 kV, 2000 kV, 1000 kV, or sometimes 220 volt only, etc., has to be converted into. That is why in the outskirts of the city, we have another power station that converts that's called substation, it is called. In a substation outskirts of the city, this 220 kilovolt that is now again converted to 11 kV. 11 kV can be again reduced into small value of about 220 volt, and that will be distributed to distributed for domestic purposes. So this is the principle of working of a transformer. There are two kinds of transformers used. One is called step-up transformer. Step-up transformer most of the time used in the power station, and the step-down transformers used at the using point, usable points, domestic points, and also industrial places. We have to convert a high voltage current, high voltage AC power to low voltage AC power, right? When high voltage is converted low voltage, current increases. Voltage decreases. When voltage decreases, current increases. That only we have to discuss in the next part of this lesson, right? Okay. So this is a very simple thing. It is consisting of two windings. One is called the primary winding and other is called the secondary winding. Both are done on the same common soft and core, right? So primary winding through which when AC, that means AC is produced and is made to pass through this primary. What is happening is that as current passes through the primary, the magnetic flux linked with the primary changes, right? Therefore, the EMF is induced in the primary, and at the same time, I mean EMF is induced in the secondary also, because whenever there is a change in current through this, the flux linked with the core changes. As the core is common for both, whenever there is a change in flux with the primary, the same flux will be there with the secondary also. So in both the coils, an EMF is induced. In the primary also an EMF is induced, and also the secondary also EMF is induced. That depends on the number of turns of the coil, right? So when current passes through the primary due to change in flux, that means whenever a current is passing through a coil, then coil means that means a magnetic field is produced inside. Magnetic field produced inside means magnetic flux variation takes place. AC current only. AC current means the current value is always changing. AC current is a current having many values. That means its magnitude is changing with the time and its polarity change periodically. So this is the condition. Means many values are there. It is increasing to the maximum, again decreasing to minimum, again goes to negative, again goes to zero, again goes to maximum, again goes to zero. Like that sinusoidal EMF it is there. So current is varying with the time. So when there is a change in current through a coil, then due to which the what is called magnetic field linked with that changes. That means magnetic flux linked with the core varies. The flux linked with the primary will be same as the flux that is linked with the secondary also. So we can write EMF is induced because of the change in flux. So this EMF in the primary, the EMF induced is given by EP. That is EP is equal to minus NP into d phi by dt. Minus sign is to remember lenses, right? Minus NP into d phi by dt. And ES is equal to what? ES means the EMF induced to the secondary. ES is equal to what? Minus NS into d phi by dt. So whenever there is a change in flux linked with the primary, when current passes through that, the same flux will be linked with the secondary also. So in both the coils, the EMF is induced by electromagnetic induction, right? Therefore, ES by EP is equal to. Therefore, ES by EP is equal. We can write NS by NP. We can write. Am I correct? So and also for an ideal transformer means that has no winding resistance. Winding is made with the help of copper wire. That thick copper wires are used in this case. Therefore, winding resistance is very less. And also flux leakage is also no flux leakage there, because what all amount of flux produced due to the current flowing in the primary, the same flux will into the secondary. Also, there is no flux leakage. That is an ideal situation. Transformer is made with an ideal condition only, right? And also no iron loss. Iron loss means eddy current loss. Eddy current we have already discussed. The eddy current loss is also not there. Why? Because we are using laminated iron core. That means the core is made with thin plates. Thereby, the resistance of the core is made increased, and also every thin plate is insulated from one another, right? As the thinner and thinner plates are used for making this core, the resistance is more. Therefore, eddy current loss is also decreased. Another loss is there. That loss is what is called a hysteresis loss. Hysteresis loss means because of variation of current, magnetic flux. That means the core will be undergoing cycles of magnetization and demagnetization. because sometimes the current will be zero, sometimes the current will be maximum. When the current is zero, the core has to get demagnetized. When the current increases to maximum, it gets magnetized. Am I correct? So when AC current flows through these coils, then the core is undergoing magnetization and cycles of magnetization, demagnetization. For that process also, a lot of energy is lost. So to minimize that only, we are using softened. Softened core used means the magnetization, demagnetization takes place instantaneously. The loss of energy due to hysteresis is very, very less. So these are the uh, losses in a transformer, right? Copper loss is there, eddy current loss is there, hysteresis loss is there, right? Iron loss is there. All these things. Iron loss means eddy current loss and hysteresis loss only. Then copper loss means resistance due to winding, winding resistance. So due to that, some energy will be lost. All these things are minimized in a transformer. Am I correct? For an ideal transformer, we can write ES by EP is equal to NS by NP is equal to VS by VP. So this is equal to voltage in the primary and voltage in the second. This is simultaneous is equal to Vs by Vp also we can write. So generally we can write ES by EP. ES by EP is equal to Vs by Vp is equal to NS by NP. NS by NP. This is equal to K. NS actually we say that NS by NP is equal to K, right? That is same as equal to Vs by Vp and also ES by EP. Now onwards we will exclude ES by EP, but Vs by Vp is equal NS by NP is equal to K. Or simply you will write NS by NP is equal to K. You will write. And this is what is called a transformer turn ratio, because this is also number of turns as secondary and number of turns as primary. This is called transformer turn ratio or transformation ratio it is called, right? K is equal to Ns by Np. Am I correct? Okay. If Ns by Np is greater than 1, that means K is greater than 1. If K is greater than 1, it means Ns by Np is greater than 1. That is, Ns is greater than Np. Then that transformer will be a step up transformer. On the other hand, if K is less than 1, if K is less than 1 means Ns by Np is less than 1. Therefore, Ns is less than Np. That means Np is greater than Ns. Then that transformer is called a step down transformer. So two kinds of transformers also explained. Also, you will see that a very interesting thing. That is this thing, all these things you will note. Right. Also, we can say that ES by EP is equal to NS by NP. Yeah. Once again, I'm writing ES by EP is equal to NS by NP. We can write. Or EP by NP is equal. Therefore, what we write? EP by NP is equal to ES by NS also we can write. ES by NS also we can write. It means what? The EMF induced per unit turn of both the windings will be same. EMF induced per total EMF in the primary by total number of turns in the primary. That means EMF induced per unit turn of the primary same as the EMF induced in the secondary per unit turn of that. That is also very, very important. And also in a transformer, the change in frequency is same. The frequency of the voltage in the primary and also in the secondary will be same. And also efficiency of a transformer is very, very high. Efficiency of the transformer is very, very high because it is prepared in such a way that there is no leakage of the flux. Other losses also minimized. Therefore, efficiency is more or less equal to 100%. Flux leakage is zero, copper loss is equal to very minimum, eddy current loss is very less, and also other one what is called hysteresis loss also minimized, right? All these things are minimized. Therefore, this the loss is very, very less. Therefore, efficiency is very, very high. So as the efficiency is very, very high, we can say that input power is equal to output power. So for an ideal transformer, we will write in the notes, but for an ideal transformer, we can write input power is equal to output power. Hence, we can write in that is output power Vs into Is is equal to Vp into Ip. We can write. So this is the ideal situation because already it is made ideally only because there is no flux leak and other losses also minimized. Therefore, what we can write Vs by Vp. Vs by Vp is equal to Ip by Is. That is Vs is inversely proportional to Is. That means this is the condition. So that means the current in any of the or Vp is inversely proportional to Ip. Vp is inversely proportional to Ip. So in any of the windings, when voltage is very high, then current will be very, very less. You take the case of a step-up transformer. In a step-up transformer, the number of turns in the secondary is very, very high. When number of turns in secondary is very, very high, means voltage is very, very high. Because you see, Vs by Vp is equal to, because we see that Vs by Vp is equal to Ns by Mp. That means Vs is directly proportional to Ns. That means Ns more than Vs is more. When Vs is more, then inversely proportional to 1 by Is. The current is very, very less. Vs is very high in the secondary of a step-up transformer. Therefore, current will be very, very less. This is very, very desirable. Why? A step-up transformer is used for transmitting power from one point to a far off point. So it is done in that way. Primary, the current will be more and voltage will be less. So in the secondary, as the number of turns in secondary is more, then the voltage is increased many times than in the primary. And hence the current will be reduced with respect to IP. IP will be more and IS will be very, very less. As this current has to flow through what is a cable wire to reduce the loss of current due to heating effect, the number of turns on the secondary is more than that in the primary. Hence, the voltage is very high, while the current will be very, very less. It can be transmitted safely without much loss and can reach the other end where the power has to be used. Then, am I correct? If case, so all these things done, IS is for a step-up transformer, NS is greater than NP. Vs is greater than Vp. Therefore, Is is less than Ip. But in a step-down transformer, NP is greater than NP. Step down NP is greater than NS. Am I correct? Therefore, Vs is less than Vp. Therefore, IP is greater than IS. So this is the thing you have to understand. From my voice also, we will again and again you will try to hear that and try to understand. Then efficiency transform is output power divided by input power. Efficiency given by eta. Eta is equal output power is equal to Vs into Is. Vs into Is divided by Vp into IP. Because actually transmissions in transmitting circuits, the cos phi actually power is equal to output power means Vs into Is into cos phi, right? Current voltage into cos phi. Cos phi is not used here because for all transmission circuits, what you see the cos phi P is equal to cos phi S is equal to 1. Power factor is very, very high. To transmission circuit, why the power factor is very, very high, that has already been discussed, right? So for all transmission circuits, the power factor must be very, very high. Then only the current will be less and voltage will be more. The loss will be very, very less. So this is what is called eta. Vs into Is divided by Vp into I. Output power divided by input power. This is transformer about. And all kinds of losses also I have discussed. Copper loss is there and also iron loss is there. Then humming loss is also there. That is always not mentioned, always not mentioned, but it is also there. Uses also I said how transformer is used for the purpose of transmission from one point to another. Long distance transmission of electric power transformer is used, and also for distribution of current for domestic purpose and industrial purpose also transformer is used. Am I correct? So these are the two electrical devices that we had to discuss that already done. right? This topic is completely finished. AC current is completely finished. And the other class, I will come with another topic called electromagnetic waves. Till then, bye bye. Thank you very much.